So 3/6 is synthetic division, and will get you to the exact same answer that polynomial division will, but it's a lot shorter. So what you're looking at here on the left and the right up top. On the left is where we do long division using polynomials, and you can see those are the kind of steps that we went through. So this is just like in the notes. This is how we did it. We worked through it. But on the right is the exact same problem worked all the way out with synthetic division. So you can see there's way less steps in synthetic division. That there is a way of doing this that we can go through and say, okay, I can do this much quicker. Now, I teach the SAT class in the afternoon, and one of the questions that people always ask when they have to divide is, can I use synthetic division? And they're very happy when the answer is yes. So let's talk about synthetic division. Synthetic division is a way of dividing two polynomials, which we have here. Now, one of the things that you have, it has to be true, is that this has to be in standard form. So the question is that in standard form?
Yes. I'm sorry.
It is in standard form, but there's one more thing that we need with this, is that we cannot have any missing variables. And what I mean by that is, if there are any powers that we are missing, like if we started at 4, then 4 all the way down to 0 needs to be there. Are there any missing powers?
No.
The squared. There is no x squared. So I'm going to fill in that gap by adding 0x squared to that. Because we're allowed to add 0 of something, right? Like I'm allowed to add 0 to how much money you owe me, and I'm allowed to add 0 to how much money I will give you, and it doesn't change anything. So what I'm going to do here is, the reason that I'm going to do this is, in a moment, this is going to hold the place for me and keep everything lined up. Yes, ma'am?
So the term on the right, does that have to be in standard form?
We'll talk about that one in just a minute. So I just want to talk about the one on the left, but the one on the right, there's some stuff for that one as well. Yep.
Isn't like when there's a variable, isn't there always supposed to be a 1? Like isn't 0x just like no x?
That means there are no x's.
So
And
just a square. Like
well, no. So it's like if I said how many $50 bills in my pocket, I have 0 $50 bills in my pocket. That's being honest right now. I have no $50 bills in my pocket. So if I wanted to represent the amount of $50 bills in my pocket, I have 0 50s, if you will. So what I'm saying is here, to do this, to be able to do this, I need all of the x's. I need x to the 4th, x to the 3rd, x squared. But you can't just add like some numbers in there and not expect it to change. But you can add 0 of something, and that won't change it at all. So here's what I'm going to do here is I'm just going to rewrite this for a moment that we've got. Yes, ma'am?
Would you also, if there wasn't an x0, would you need to add that?
Yes. So her question, if there wasn't an x to the 0 power, will I need to add that? Yes, I would. Does this have an x to the 0 power?
yes.
Yes, it's attached to the -6 because remember, x to the 0 power is just 1. So here's what I did is I just rewrote it. Oh, I didn't rewrite it. I started talking and my hand got writing faster than my brain could work. 13x minus 6. So all I did was rewrite that with the missing thing in there. It's missing, like the one that was missing, divided by x plus 2. Now the next question I got is, does this one have to be in standard form as well? Yes, it does. That one needs to be as well. So in this case, I've got x to the 1st power and I've got x to the 0 power, so we're okay. Nothing is missing there. There's nothing in between the highest and the lowest that is missing. So we always start at the highest one and work our way down. So here's what I want you to do. When we have here on the right the divisor, the thing that we are dividing by, when x is all by itself, this is a perfect situation. So I'm going to show you a different situation on number 2, but for right now, just understand that this is the best situation because we are going to take this number right here and we're going to make a little backwards L. Every single time, 100% of the time, you're going to make this backwards L. And you see that up top, you see that there's this backwards L up here, we're going to make that. Except for, in this situation, there was a -3 out front, and they wrote a +3. So what we're going to do is every single time, instead of writing this number, we're going to write the opposite of that number. So instead of writing 2, what am I going to write? -2. Now I'm going to scroll back up for a second. Let's take a look at the polynomial long division on the left and the numbers on the right. Tell me what you notice in common between these and these. What are similar about those two things? The coefficients are exactly the same. If you look on the left, you see a 2x cubed, a negative 10x squared, a 9x, and a 15. Look on the right. 2, negative 10, 9, 15. So all we're going to do here is we are going to write the coefficients, meaning the number that's out front of each of these. So tell me what numbers I'm going to write. 1. Oh, sorry, let me get that. There we go. 1. Negative 2. I'm leaving myself a little space here. Then 0. 13. If you can believe it, you've done the worst part of synthetic division there. That was the hardest thing that you have to do.
Why did you do negative 2 again in the beginning?
Oh, because, so I'm going to show you a different example in a minute, but when you have x all by itself like this, when there's just an x, when that variable is just by itself, all we're going to do is take the opposite of this number. Now I'm going to show you something different here in a minute, but I'm just taking the opposite of that number. And the opposite of 2 is? Negative 2. Notice up here that this was x minus 3. They had x minus 3 in parentheses, like this. So they put positive 3 out front. So we're just putting the opposite of that number. So let me show you in just a minute. Let me show you in the next one. It's going to make sense as to why. Because in a moment, when we get to the next one, you're going to be like, wait, what? I got to do what? And then I'll go through the explanation of to why it is that we're using the opposite. Okay, so synthetic division is so much easier because instead of subtracting, we are going to add all the numbers. But the first thing that we have to do, you have to do every single time, is bring down. Every single time. So we're going to bring that 1 down. And this negative 2 over here, we're going to multiply it times 1. What is 2 times negative 1? I'm going to write that number in this slot right here. And I'm going to add the next column again. What is negative 2 plus negative 2? Negative 4. I'm going to do the exact same thing again, and I'm going to multiply negative 2 times negative 4 to give me a positive 8. I'm going to add the next column. What is 0 plus 8? 8. I'm going to multiply again. Negative 2 times a positive 8 is a negative 16, and I'm going to add again. Negative 3. Guess what my next step's going to be? I'm going to multiply again. Negative 2 times negative 3 is? And negative 6 plus 6? Okay, so let's talk about what these numbers mean now, because we are basically done. There's no more work to do. You've basically done all the division that you need to do right there. So everything that you did on the polynomial long division is being done right here. But here's the thing. Remember when we did polynomial long division and we got to this last number there? What did that last number represent? That's the remainder. So guess what the last number here represents? That is the remainder. If there is 0 remainder, it means there is no remainder on this one. Now, that's not always going to happen. That just so happened on this one. There is no remainder. Yes, ma'am?
So if you go back,
All right, let me finish this one up and maybe it'll make sense. Now, here's the only thing that's missing. I can't write that as the answer because that wasn't our answer when we had the polynomial long division. It had a bunch of variables on it. So I'm going to put the variables back in. Watch this. I'm going to put an x on every single one of these. And starting from the right, I'm going to go from the right. So watch this. I'm going to go 0, 1, 2, 3. And our work is basically done because what is 1x to the third the exact same thing as? X to the third. And what is negative 4? Well, that just ends up negative 4x squared. That can't be simplified anymore. What does 8 times x to the first power end up as? What does negative 3 times x to the 0 power equal? 1. Negative 3 times 1, which is... That's a negative 3. Because remember, this part right here ends up as a 1. And 1 times negative 3 is negative 3. And there is no remainder. That is all the division done right there. Now, you may not have this yet because this is something new, but I can trust you by the third problem, you're going to go, oh wait, this is so much easier. Way easier, and I'm telling you, most people would rather never go back to polynomial long division again once they find out this way. So here's what we're going to do. Yes, ma'am?
I'm still kind of confused what you were adding.
What do you mean where
The -2, the 8, the -16, and the 6.
Oh, where did I get those from? See these lines that I'm drawing here? I did -2 times 1, and that gave me -2. Then I did -2 times -4 and got positive 8.
So you're multiplying.
Can we do one more and I'll show you on the next one? And then if we're still stuck, we'll go over it in a little more detail. Let's go to the next one. Actually, I want to skip B and go directly to C because B is the hardest. I want to do B last because B is this weird explanation. So here's what I'm going to do here. I'm going to start on C, where B is going to be our last one. We're going to do C. I look at C and I see two things. First of all, on the left, is this in standard form with all the terms there? Yes. I have an x squared, I have an x to the first power, I have an x to the 0 power. On the right, I notice that x is all by itself, which was that great situation that I told you about. When there's nothing stuck to x, this is a great situation. So here's what I'm going to do, the exact same thing as last time. I'm going to draw a backwards L. Now, I am not going to write -3 in there. What number am I going to write in there? The opposite of that number, which is +3. Next to the +3 on the other side of that backwards L, I'm going to write some numbers. And those numbers are the coefficients of these right there. So what numbers will I write? 1, 5, and -28. That's where these numbers came from. 1, 5, -28. So far, so good? Stop me if I'm doing something you don't like. Yes, ma'am?
So you drop it back.
No, we're dropping the x's to make our life a lot easier. We're going to pick them back up at the end. All right, here's the part where we just follow the steps. Every single time, what did I say I was going to do with that first number? Bring it down. And now comes the multiplication part. 3 times 1 gives me what? 3. Add the next column together. 5 and 3? 3 times 8 gives me? What is -28 plus 24? A -4. The hardest part of this is done. We're basically done at this point. What does that last number represent? The remainder. Now you're going to be like, why do you keep writing r next to it? Because I have found that in the beginning, if you don't, you will forget that it's the remainder and you will try to put an x on it. Don't put an x on it, that's the remainder. So here's what I know. At the end, it's going to be -4 over something. Where did we find that thing that went in the denominator?
If it's higher than me, I understand you added 35. Never mind.
Are we good? Okay, if it's any side questions, give me just a minute. Let me finish this question because this is the part I want to do. This is my remainder. -4 over what? Remember when we did polynomial long division? Where did that remainder come from? X minus 3, same place, no different. Now that's the remainder. But these two things that I haven't touched yet, these two right here, they need x's on them, and I'm going to put them on there because they don't have them. So here's an x. And here is an x. Now remember I said start from the right and start with 0. So even though we started with squared, we're always going to be smaller than that one. We should never be bigger than that one. We're going to get smaller. Because when we divide things up, they get smaller, right? If I take your money and I divide it up into, I don't care how many piles, it's going to get smaller in each pile.
So you start from the right.
The right.
And you go 0, 1.
Right, I've got my remainder, then I've got 0, 1. If I had more things, I would keep going. 2, 3, 4, as many as I needed. But now let's just decide what that's the same thing as. 1x to the first power is the same thing as? And 8x to the 0 power is the same thing as? 8, because that's 8 times 1. So guess what? Our answer is already done. I'm just going to rewrite it so it's a little prettier. x plus 8 minus 4 over x minus 3, division done.
You just put them side by side like that.
Right, because it's a part of it. Like if I said that like, let's say we do this work right here. 6 goes into 8 once, and I get 2. This becomes 1 and 2, 6. They go together.
Mm-hmm.
So it's a 1 and 2, 6. In this case, that is a -4. So it has to go together just like that. It's a part of it. The 2, 6 is part of that number there.
Mm-hmm.
Granted, that 2, 6 could be reduced, but whatever. That's just an example. Yes, ma'am. Go ahead.
How'd you get the 24?
So we went like this. We did 3 times 8 gave me 24. 3 times 1 gave me 3. We're going to do a bunch more. Don't worry. Yes, ma'am.
And then is there a reason why you do it to backwards zone? Like is that like something you have to do?
It's to separate it. We just need something to separate it. We could use something bigger, but we're just trying to separate it.
So it's the same thing as like dividing.
Sort of. We're just trying to make everything nice and easy and lined up. And you're going to see once you do synthetic division, it actually can help you solve equations very fast. Like instead of doing all the work that you had to do before. It's going to be one of those things that you'll be annoyed with me later that you didn't, like, why don't teachers teach us this earlier? Because this will get us through so many of the problems that we used to have to do so much work for. Yes, ma'am.
So on quiz or test, are we gonna have to do the other separate
Ooh, this is the most brutal question because the answer is yes, and I'm sorry to that. Her question was on a quiz or a test, will I have to do it the other way? If my test asks you for long division, then I'm expecting to see polynomial long division. If it asks for synthetic division, then you have to do synthetic division. If it doesn't say either way, then you get to choose.
Like, don't use it, get the right answer.
You get 0 points. If I say that I want you to use a shovel and dig up my backyard and you use a bomb, I'm not giving you credit for that. Like, I asked you to do it a specific way, it didn't happen that way, then...
But your backyard is...
Okay. Think about this from my perspective, and honestly, like, let's not be like silly for a minute. Is that I go, there's a lot of like in the homework, like, what if you didn't show your work and you just use a calculator to get to the answer? Didn't that still get the answer?
Yeah.
It still gets the answer, but you didn't do it in the way that was expected of you. Because you know that, like, even when it comes to homework, the thing is, I'm pretty forgiving of homework if you are doing your work on it. Like, I get it. Math is hard. Like, we're not getting the right answers all the time. And I will give you points for that if you show me what you are doing. All right, let's go to D. Let's look at what are the 2 things that I'm checking for right away before I start?
Standard form.
Standard form. Okay, is this in standard form?
Yes.
It is in standard form, but
It's missing X.
it's missing an x to what power? To the first power. Now, I can't just throw in however many x to the first powers I want, but I am allowed to throw in how many of them? 0. You can throw in 0 of something and it doesn't matter. So I'm just going to rewrite this. 3x cubed plus 4x squared plus 0x plus 10 divided by x minus 2. What things am I checking for the divisor, this right-hand number? It's in standard form, and there's nothing stuck to that x, because you're going to see something different happens when it's stuck to that x. I want to get this one down, and then I'll show you the odd situation, like what happens when this is in there. All right, so guess what number I am going to put on the side of this backwards L? Yes, ma'am?
2.
A positive 2, not a negative 2, a positive 2, the opposite of that number. Now I need some numbers on the other side of that L. What numbers will I use? 3, what up? 4, 0, and 10. Now here's the part that it's like most people are just like, I just need to get this down what the steps are. What do I do with the very first number?
Bring down the 3.
Bring it down. Okay, now that I have a 3 down there, what do I do with it?
You multiply by
2
2.
times 3.
2 times 3, which gives me
6.
6.
And you add 4.
Okay, 4 and 6 gives me 10.
10. And you multiply 2 times
Killing it. 2 times 10 gives me
20.
20. I add those together and get 20. Next,
You multiply 2 and 20. 40.
which gives me 40,
You add the 10 and the 40 and
50. What do we call that last number there?
remainder.
That's the remainder. Again, I'm going to put that there because I don't want myself to forget. Well, each of these need an x. Or whatever variable. If we were dealing with y, we'd put a y. So like we're just using whatever variable they have there. Now, what about their exponents there?
Start from 0, from the right.
Uh-huh. Good. From the right, going to the left, starting at 0, going up as high as we need to. 0, 1, 2.
The remainder is just like disregarded, like it doesn't have any x or anything. It's just
Right. There's no x on the remainder. Yes, ma'am.
For the exponents, you go like backwards.
Right to left. 0, 1, 2.
Okay.
Because we want it to end up in standard form, right? And that's the only way that's going to happen. Here's the problem. Well, why don't I go from the left to the right? Because I don't know what number it goes up to. This might go up to 3, it might go up to 5, but if I start at 0, I will always be okay if I start on the right.
So it's always goes right to left.
Did they give you a pass? I need a pass? Okay. Okay, so let's simplify this now. Well, 3x squared can be simplified. It's just 3x squared. But what about 10x to the first? How could I rewrite that? Just as 10x. So that's a positive 10x. And what about this 20x to the 0 power? That's just 20. And then how do I write that remainder? Let me zoom out for a minute. How do I write that remainder? That's a positive 50 over x minus 2.
Wait, why wouldn't you put the x after? Oh, wait, no.
You can't simplify that?
No.
Be in the 2.
No, that's a good, so her question is, can I simplify that? No, because the 50 needs to be divided with the x, and it needs to be divided with the negative 2. So no, that can't be, because I don't know how to do that 50 divided by x. So that cannot be simplified. 50 over 2 could, but not 50 over x minus 2.
So whenever you have a variable, you can't, unless it has like,
Unless I know what x is, I can't simplify it.
Okay.
All right, let's try another one. Here's where you guys impress the heck out of me, because I'm going to shut my big mouth, and you guys are going to tell me what to do. Take it. Delissa, it's all yours.
You put it in standard form first, so.
Here? Yep. Is it in standard form?
Yes, it is.
Am I missing any terms?
Yes, you are.
Which one?
You're gonna do plus 0x between 7x and 9.
So wait, which?
Is that 0?
Okay, so there's a debate. So she's, I think her question is, well, where the heck is x to the 0 power?
Oh, it's right there.
It's actually right here, because that's the same thing as times 1. It's actually, the x to the 0 power will always be attached to the constant, or the actual number that is there. If there was no number, let's pretend there wasn't a number here. Let's pretend that this wasn't there was nothing. It just said 2x squared plus 7x. Then guess what? If that were the case, I could add 0x to the 0. But that's not the case. That's not the case. We don't have that. Looks like we've got everything that we need. What do you, yes, ma'am, keep going. What's up? What, you stuck? You don't need to be. You're doing great. Everything that you need is there. There's no trick at the beginning of this one. Okay, I've got x by itself in standard form, so what can I do? A positive 2 over here.
And then next to it, you're gonna have 2 plus 7 and 9. And then you're gonna bring the 2 down. And 2 times 2, which is 4. And then the 11, right?
So far, so good?
And then the 2 times 11 and 22. Do you subtract that or do you add?
Always add on this one.
Okay. 31. And the remainder would be 31. And then we put 0 in there as an exponent for 11. And 1 for 2. And then
I could not have done that better myself. That was perfect. 100% perfect. That's exactly what we're doing on each one of these problems. Now again, B's a little bit different. We'll talk about why B's different in a minute. Yes, ma'am?
On the test, can you do it both ways? Just
If I ask you, you could. So that's a great question right there. She said, can I do it both ways to check? For sure. But if I do ask you to do polynomial long division, I need to see the long division. But she's saying, can I check it with synthetic? You bet you can. They will come out to the same answer. But I don't know about you, but I'm already feeling like this is way easier than the way we did yesterday, right? Like, how many people feel like this is better? I feel the same way. If you don't, that's cool. You don't have to be part of this crowd. But I'm just saying, for me, I never do it the other way. I know how to do it the other way, but I always choose this way. Yes, ma'am?
How come, I don't understand why you don't add the zero.
Why you don't what?
Add the zero.
What zero?
Because the last problem, it was a 10, and Louise is added the
Because it
zero.
wasn't in standard form.
Oh, you're saying why did we add this 0x to the first? We didn't have an x. We had an x to the third power. We had an x to the second power. We had an x to the 0 power, but we were missing the x to the first power. We needed to add that in there. Whereas this one, we had the second power. We have the first power. We have the 0 power. We're not missing any.
Oh, so you only add the zero when you're missing.
When you're missing one. All right. Somebody hook me up with F here. It's no different. I'll let you know if something's troublesome. Go for it. What am I checking for first? Let's talk about the process.
It's in standard form.
Is it?
Yeah, no.
Well, it is in standard form, but
It's missing 2x2, so you're
It-
going to put it 0x2, and then you're going to check the other one on the right, and it is in standard form.
okay.
So you're going to rewrite it x4
X to the fourth.
minus 2x cubed plus 0x squared plus 3x plus 1. And you're going to make the other term too. And then you're going to make the backwards L, and you're going to put 3 in it, and then you're going to drop down all the coefficients
Okay.
from the first term.
Look at you using fancy words. All right. 1.
-2, 0, 3, and 1. And then you're going to make the line. You're going to drop down the 1.
Dang, bro. Look at you go. Go. Keep going.
You're going to multiply 3 times 1 and put it there. And then it's going to be 1. And then you're going to multiply 3 times 1. It's going to be 3. And then you're going to add that and it's going to be 3. 3 times 3 is 9. 9 plus 3 is 11. 11 times 3 is 33. 33 plus 1 is 34. And then you're going to add, 34 is going to be your remainder. Then you're going to add all
Wait. I can't keep up. I can't keep up.
Yeah, 12.
Yeah.
Which one? Oh.
Oh, so we need to go back. Okay.
Yeah.
So we're going to go back because that changes some things.
So 12.
Oh, sorry. That was a 9. I clicked too much. Don't worry. I'll get you back up. I'm sorry. I got so crazy. I got click happy there and I was just having a ball. 3 times 1 is 3. That becomes 3. 3 times 3 is 9. That becomes 12. Let's take it from there.
3 times 12 is 36.
Okay.
36 plus 1 is 37. 37 is going to be your remainder. Then you're going to put x's on everything except your remainder. And then you're going to go from right to left. 0, 1, 2, 3. And then you're going to simplify it, so it's going to be x. 1, or x, or just x. Or,
X like that?
no, the next term.
Oh, the next term. Okay. Just x?
Yeah, x. 3x. Yeah. And then 12. I feel like I definitely did that part wrong.
Only a teeny tiny bit. And everybody's waiting to jump in and save you here.
Oh, that's squared and then cubed.
Ah, so we forgot the cubed. We forgot the squared. What should be in between these things?
Oh, a plus.
Right.
12. And then you're going to put 37 over x minus 3. And you can't simplify that.
There's only one teeny tiny little thing. It's so teeny tiny, but it would be the kind of thing that I would take off points for. One teeny tiny thing. It's a good question. What is missing there that I would take off points for? Plus. That's a positive. Because we're adding this too. We have this. We have all of this plus that. Anyone would. Any math teacher would. And I actually, to be honest, if there was a math teacher that wouldn't, I would like to have a conversation with them because...
So you're adding both together?
Yeah, because what we're saying is that when we divide them, we get this,
Yeah.
but also this, which is added on to there. Like
So every single time it remains, you have to put plus or minus.
plus or minus. Yeah, so if it was a negative 37, that would have been minus. If it's a positive 37, that would have been plus. And it's teeny tiny, but I know you would hate me at the end for like, bro, I just did all that work and you knocked me off for a plus. Yeah, I would. So I would rather...
Wait, so you would give like half a credit?
Yeah, I would. I'd give half credit. For sure. But you're asking me, would I take off points? Yes, I would. I know. It just is what it is.
But you already know it's positive.
I already know it's positive, for sure. I do this all day long.
No, like you already know it's positive. You don't put a negative.
I understand, but look, how about this? I just wrote down two numbers.
Yeah, but both positive.
Oh, use that 63 because I meant 6 plus 9, or 6 plus 3 is 9. So that I can't write 6 plus 3 like that?
That's funny.
I know it's not what you mean, but what you say and what you mean are not the same things. If you want to say that those two things are together, they need to be added together. If this is like a subtraction at the end, it's minus 37, then it needs to be subtracted. We can't just say, oh, you knew that. Yeah, I knew that. You're not going to win this debate, just in case you want to fight it out. You're going to lose, and it's going to be a long process for both of us. All right. Whoa. Hey, bruh.
Mr. Hart.
Windows has encountered an error. All right, we got two more. This one, which hopefully will go pretty quickly, and then the one that is only slightly annoying because something's different. Somebody else, hook me up. Take it away.
Okay, so it's in standard form?
It's in standard form. Any terms missing?
No.
Okay.
Okay, so do a positive 6 in your L. Then you're gonna do 1, negative 3, negative 18. Then you're gonna add, bring the 1 down. 1 times 6 is 1. 6 is 3. Negative 3 plus 6 is 3. 6 times 3 is 18. Negative 18 plus 18 is 0. 0 is your remainder. Put an X on every over. And then from right to left, go 0, 1, the X one. And then simplify it, X plus 3, and that's it.
Done. We can wait, please. Let's go to an ugly one. You like me just fine. Ayo. Okay. Something is different about this one. What do you notice is different about it? This. We've never had this before. So that little rule that I gave you works because of this. So when we had, forget about this problem for a minute. Let's go back. When we divided by x minus 3, whatever was on the left, you knew that you had to take the opposite of the number. Here is why you had to take the opposite of the number. Because x minus 3 is equal to 0. And when we were to solve this, we would add 3 to both sides. And we would get that x is equal to 3. When we solve that, we would find out that x is equal to 3. So in this case, here, we can't just take the opposite, and you cannot just use the opposite of this number. In this case, we have to do this. 2x, when it's anything but x, when we've got anything but x there, like it's something else, 2x plus 3 equals 0. What's my first step? Ooh.
On both sides. Minus 3 on both sides.
Give me 1 second, Riley. I got your question. I'm not going to leave you hanging. Don't worry. Negative 3, and then?
Divide.
And then divide? So the one that we're going to use, for this one is negative 3/2. And that you can't see that from looking. Now, Riley's question was, why did we do that on this one? The truth is, we've been doing it on every single one. I'm just not showing that work. X minus 3 is equal to 0. That, when you work that out, becomes x equals 3. When we had this one here, x minus 2 equals 0. When we work that out, x is equal to 2. When x is all by itself there, it's just as easy as taking the opposite. But when x is not by itself, it's not that easy. So the number that we need to write on here, over here, is actually negative 3/2. Not only was that difficult to find, it's also a fraction. Bum, bum, bum.
So when you have a coefficient, like
You bet. If you have any...
to turn into a fraction?
Exactly. If you have anything else there, you need to solve that for 0. 2x plus 3 equals 0, and we figured that out, that was equal to negative 3/2.
Wait, does you have to flip the sign then?
Why would we flip the sign?
You put in the box, in the
No, because look, remember when we solved this, x minus 3, we knew we were going to use a plus 3, right? Why did we use plus 3? Because x minus 3 equals 0. When you add it, when you actually solve it, it's already at the opposite version. So when we solve this one, it's already at the opposite version.
Okay, so you solve, don't mess with
Right. Now the truth is you can solve every single one of these and you don't have to do the opposite, but why would you? I mean, I don't want to do that every time. Yes, ma'am.
Wait, but would you have to turn the 3 negative?
No, because that's what she just asked. In this case, we know that we're going to use a positive 3 there. And why did we use a positive 3? Because if we solve this, it ends up as x equals 3. I have 5 minutes. I got to get through this last one, so give me a second if you have questions. This math takes a little bit more work because it's fractions. So, standard form. I've got 3, 2, 1, 0. That's great. I'm going to put up my coefficients. 6, 7, 1, and 1. Are we all okay with what I just did there? Okay. I'm still going to do the same thing. I'm going to bring down a 6. Now, here's where the work comes. I have to do negative 3/2 times 6. Well, 2 goes into 2 once, and 2 goes into 6 3 times. This becomes what? Negative 9. Add those together. That's what 3/2 times 6 is. 3/2 times 6 is negative 9.
You want to see
I'm sorry, negative 3/2 times 6.
Do you want us to show us like multiplying?
Yeah, because most of you are not doing that in your head. I mean, honestly, you're not. I'm not trying to be funny. Is that like most people, if you're multiplying fractions, you have to do it. So I'm sorry, 7 plus negative 9?
negative 2.
I can't go back to the fractions yet. If you have problems multiplying fractions, come after school. I will help you with that. That's way back. I can't go back to that just now. Okay, now I'm going to do negative 3/2 times negative 2. Negative 3/2 times negative 2. 2 goes into 2 once. 2 goes into negative 2 negative 1 times. What does this work out to be? Positive 3. Because a negative times a negative is a positive. 3 plus 1 is?
4.
4. And now we're going to do negative 3/2 times 4. Negative 3/2 times 4. 2 goes into 2 once. 2 goes into 4 twice. What does this become? Negative 6. What is 1 plus negative 6? Negative 5. Now we can do all the same stuff that we did before. What is that negative 5? It's the remainder. Put x's on everything else. 0, 1, 2. Let's simplify this. 6x squared
Minus 2x.
minus 2x
Plus 4.
plus 4.
Minus 5 over. You still do 2x. Plus 3.
2x plus 3. Same exact steps. What was difficult there is two things. When that wasn't an x by itself, when the divisor, the little thing on the right, when it isn't just an x by itself, you have to solve it. Set it equal to 0 and then solve it. And then once you do, that is the number that you are putting over here. And then this became even harder because it was a fraction that we were multiplying, and people don't like multiplying fractions. I get it. I know, because I see everybody's reaction when I see you have to multiply a fraction. It is clear about how you feel about that. Felissa, you had a question, though.
I get it.
You're good?
Yeah.
Gabby, you had a question?
When you're multiplying fractions, can't you just go like across directly?
Yes. So you would have gotten the same thing. Now, I cross-cancel because I actually find that it's more work if you don't. If I had done negative 3/2 times 6 over 1, I would get negative 18 over 2, which then still becomes negative 9. So if you want to do it that way, it's fine. It's just your numbers end up bigger and end up more work. So for these problems, it says use synthetic division to evaluate. When we talk about evaluate, what?
Substitution.
Did I what I say? Sorry. Excuse me. Using synthetic substitution to evaluate. Sorry, I did say division. Using synthetic substitution to evaluate, which is just like synthetic division. So when we evaluate this, normally what you would do, that says p of x is equal to x to the third power minus 4x squared plus 3x minus 5. Don't write what I'm about to write because I'm going to show you the long way that you used to have to do this. You would write p of 4, meaning I'm about to plug in 4, and I would get 4 cubed minus 4 times, what am I plugging? Oh, 4. Minus 4 times 4 squared plus 3 times 4 minus 5. And I would have to go and work all that out, but actually there's a much easier way to do this. So what we're going to do to solve this, instead of going and plugging that in over and over again, the truth is, if we were to do this just like synthetic division, except for we're going to find out what is the remainder. Whatever the remainder is, that is going to be the answer. When you plug in 4, the answer that you get there will be the exact same thing as the remainder if we do this like substitution, like synthetic division. So here's what I'm going to do. I'm going to do that little backwards L. But when it comes to the part where I am evaluating, I'm not going to use the opposite of this number. Notice that this is not set up like there. I'm just going to use that number right there. I'm just going to put a 4 right there. But everything else will be the exact same as synthetic division. So what numbers are going to go to the right of that? 1. So here's the 1. That's where I'm getting the 1 from. What else? -4, which came from right here. 3 and -5. Just in case, you can see all the numbers that are underlined up there. That's where I'm getting them from. Now here comes the part that is exactly the same as yesterday. So I bring this down, and then what do I do with this? 4 times 1 gives me 4. Now what do I do with that -4 and that 4? Add them together and I get 0. 4 times 0 is 0. And then what do I do with that 3 and that 0? Add them together and get 3. Now what do I do with this 4 and the 3? And I get 12. Add 12 and -5 together and I get? So guess what? I think this is way easier because the truth is that if you were to take 4 and plug it in there, the final answer would be exactly 7. So instead of plugging that in and doing all that math, there's another way to do it that you can use synthetic substitution, which is actually way nicer. I don't know about you, but like that's actually kind of nice. Like you're sitting there and you're going, oh, okay. So I made sure that I had all my x cubes, I have my x squared, I have my x, and then all I did was the same things that I did for synthetic division with the exception of one thing. I didn't use the opposite of this number, I just used that number. Yes, sir?
You know it's synthetic substitution when it doesn't have the x plus 2 or x minus 2, but it has an equal sign.
Well, this one, like let's say that I gave you this question on the test. It would literally say evaluate, and it would have like p of x is equal to this. There's no division up there. It's not like the others that we had where it's showing division. Now, can I just show you something real quick, and you don't have to do this part, just so that you can see how much longer it would have been? I'm actually going to do that math that I did right here, where just to show you how much longer it takes me. And I'm going to do it quickly. I'm not even going to sit here and I'm not going to play around. I'll go p of 4 is equal to 4 to the third power minus 4 times 3 squared plus 3 times 4 minus 5. Now I'm going to do this. So, yeah.
It's 4 squared.
Did I miss something?
Yeah.
Oh, I plugged in a 3. You're right. I said 4 and then I plugged in a 3. Thank you. It's still very early. 4. Everything else is good though? Let me just double check myself. 4 to the third power minus 4 times 4 squared plus 3 times 4 minus 5. All right, so I'm not even going to lie. I'm going to show you I can do the numbers pretty quickly, but even so, it still takes me longer. P of 4 is equal to, now I know 4 times 4 is 16, and one more 4 would be 64. You may or may not have known that, but I'm just trying to show you that. Okay, so we go 4 times 16, because 4 squared is 16, plus 3 times 4 is 12, minus 5. Now I still got to work this. So we get P of 4 is equal to 64 minus 4 times 16 is 64 plus 12 minus 5. Then P of 4 is equal to 64 minus 64 is 0 plus 12 minus 5. And then I get down to P of 4 is equal to 12 minus 5, or P of 4 is equal to 7. Now, I think you would say that I did that pretty quickly. But even so, that still took me longer than it did to do all this. And like, let's face it, my guess is that if you're not, like if you don't know what 4 cubed is off the top of your head, it's probably going to take you a little bit longer than it took me, because I do this problem all the time. Like for me, I'm like, I've done this a million times. No worries. I have a lot more practice in it. So this synthetic substitution is a much better way of doing this. It's a much quicker way, at least, of getting to the answer. So let's try it again right here for number 6. Let's use synthetic substitution to solve this. Now, remember, in this case, with synthetic substitution, I do not need to take the opposite of this number. I'm just going to take that number. So somebody help me out. Talk to me about what we're going to do here. Beautiful. Negative 3. Okay. And now what are the numbers I'm going to write here? 1. 1, 3. Beautiful. Why 0? There is no x to the first power, so I need an x to the first power, so we're putting a 0 in. Outstanding. Where am I going from there?
Multiplied by negative 3. 0. Then you multiply it by negative 3 and then make 0 again. And then you put 0 at the bottom, and you multiply by 0 again. And then you get 4.
So what this tells me is that if I were to plug in negative 3, the final answer will be 4. In all of that up there, instead of doing all that math there, instead of doing negative 3 times negative 3 times negative 3 plus 3 times negative 3 times negative 3 plus 4, you could just do this and find out that the answer is in fact 4. Yes, sir?
So instead of the last number being the remainder, it's the solution?
The remainder is the solution, yes. That is like, that remainder there is the solution. So this is different than synthetic division. This is synthetic substitution. But you'll recognize it's different because notice there I didn't tell you to divide anywhere. Distracted there for a second. All right, so here we go. We're going to do another one here. We've got x is equal to negative 1/2. Well, that's going to be a little tough because we are going to be multiplying 1/2, but it's not like it's something we can't do. We've got negative 1/2.
0x2. X2.
Oh, he's saying make sure you put in a 0x squared. Okay, perfect, because we're missing the x squared, so we got to make sure that we account for that. All right, so let's do our numbers. What numbers am I writing? 4, 2, 0, 3, 4. And again, those numbers are coming from right here. 4, 2, 0, 3, 4. Bring down. And now what? Okay, negative 1/2 times 4 is? Negative 2. 2 plus negative 2? Is 0. 0 times negative 1/2. 0. That was nice. 0 plus 0 is 0. Well, this is a difficult one then. Negative 1/2 times 0. 0. 3 plus 0 is 3. This is maybe the only one that takes a little thought. Negative 1/2 times 3 becomes negative 3/2. Now, to subtract this, let's say you're stuck with this. You're like, ugh, I hate subtracting these. So just turn this into halves. So we've got 4 over 1. Since we need halves, we're going to make sure that these look like halves. Something like 4 over 1 is equal to some amount of halves. Well, what did I multiply to get from 1 to 2? What did I multiply by? 2. So let's do the same thing up here. And so 4 over 1, or 4, is the same thing as 8 halves. So we get 8 halves. Plus negative 3/2 leaves me with 8 halves. 5. Yep, 5 halves, which is my final answer there. So that the final answer I would write like this. P of negative 1/2, meaning what I plugged in was negative 1/2. If this said f of x, I would write f there. This just says p. So p of negative 1/2 equals 5 over 2.
So we would write that, that would be the answer for if it says evaluate.
Yep, this would be the final answer right there. Meaning that when I plugged in negative 1/2, the final answer will be 5/2. And the truth is, think about it. Would you rather do what we just did, or would you rather take negative 1/2 and plug it into this whole thing there? I don't know about you, but I would very much dread plugging in negative 1/2 into there.
It would also be fun if you did a mixed number, decimal point.
Yeah, so he's saying, is it okay to do this as a mixed number? Sure, as a mixed number. Just think if you wanted to convert this. But here's why I say maybe don't, because so 2 goes into 5 twice. With one remainder, that becomes 2.5. But let's say I made a mistake in my division right there. You had 5/2, but then you converted it to something different. You're going to lose points for that if you convert it to something that is not correct. Like let's say I accidentally got 3 1/2. I would just say you had it correct here. Why not just leave it there? So I'm okay with you making it a mixed number. I'm okay with you making it 2.5. Just understand that the more steps you take beyond the answer, you just subject yourself to more criticism. I go, let me take a look at your math. I'm going to take a look at the math you did. If something's wrong there, because really what you're saying at the end is like, let's say that I get to the end and I go, oh, that equals 3/2, which it doesn't. It doesn't equal 3/2. And I go, there's my final answer. Well, you just told me your answer was 3/2. Even though earlier it says 5/2, which is not the same thing. Sorry, this does not say 3/2. It says 3.5. Excuse me. 3.5 is not the same thing as 5/2. So I would just say, just be careful with that because those little mistakes can come back to bite you. All right, last one, and then I will leave you to work on your review, and I will leave you to work on your homework. Somebody talk to me about this one.
Do the backwards down to 1/5.
Beautiful.
Then you put 5, 9, 3. Then you bring down the 5 and multiply by 1/5, which is 1.
1/5 times 5, just in case you're like, lol, what? Becomes just 1. Oh, sorry. 9 and 1 is 10.
And then it's 2.
That becomes 2. So what this tells me is that if I take p of x, if I take this function and I plug in 1/5, that the final answer will be 5. So like if you can remember this, even when it comes to things like, oh, I got to do this on SAT, I'm going to have to do this next year in math, whatever it is, this is a nice little trick for not plugging in over and over again. Actually, it's really nice. One of the kind of things that I bet you knew earlier because it's a much shorter method. Will you get to the same answer if you plug in? Yes, but it's way more work. Like think about it. If nothing else, if you do it that way, at one point you're going to be doing 9 times 1/5. That's not as easy as 10 times 1/5. That's a little bit harder. It'll still work out to the same answer, but this is much prettier down here.